All right, hello everyone. Sorry that I once again couldn't be here, but here we go. We're going to be learning about determinants of square matrices. This is more or less just an operation that we're going to take a look at. Maybe not unfortunately, but the depth of problems that we're going to go into in this unit most likely won't require that we actually apply this very often. But there are a few things that we're going to learn we can use these determinants for. So first off, what is a determinant? Well, a determinant is a real number associated with a square matrix that can be used to find inverses and solve systems. Now, once again, because of the size of the matrices we're working with, we likely won't use this for those purposes, but it's just meant to be an introduction to the actual process since it can be pretty useful. So first off, the determinant of a 2 by 2 matrix is somewhat unique, although the method that we're going to learn that it works for larger matrices will work on a 2 by 2 as well. If we have a matrix that looks like this, what we're basically going to do is cross multiply. Okay? So in other words, if we want the determinant of A, and again, this is the symbol for determinant, it has nothing to do with absolute value. We just cross multiply the first cross product here, A times D, and subtract the second cross product, C or B times C. Now we subtract them. Now the reason we subtract them is we're going to find out, and we'll look at a more complicated version, but basically when we're using this process, there's a relationship where the coefficients of the parts that we're multiplying, and again, this will make a little more sense when we actually apply this with the problem, ends up being negative. So in other words, I have the A here that I'm multiplying by, we see that here, that's positive. Now the B, when I use that, and basically we're multiplying B times C, that it's going to be negative. That's where this negative comes from. All right? All right. All right, so now we look at how to find the determinant for a few specific examples. Really focus on getting the first example down here and the last one. The second one I'll go through relatively quickly, so you have you can kind of see another example here. So first off, we go ahead and again, we're taking that kind of cross multiplication. So we take our first term here, multiply it times the 5. You can see that here. Okay, then you're going to go ahead and take the second term in that row, the -1, times the 3. You can see that here. And again, since in that kind of generic plus minus thing that again we'll look at in more depth in a moment, we have plus here, minus here. So this we are going to subtract the second product here. Okay? And again, if that's getting a little confusing for you, just the first one, you just take the first cross product and subtract the second cross product for a 2 by 2 matrix. Now we're going to add all of that up, make sure that we're really careful with our negatives, and we find that the determinant of this one is 13. Next example, same thing. We take the -1 times the 4, then we subtract that second cross product of 2 times 6, and that's going to give us our determinant. Okay, and the last example, again, same process here, okay, but with this process, what we're going to find is we have a determinant of 0. Now that has a special meaning. What that tells us is that this matrix C has no inverse at all. Okay, so what we can do is we can actually see that with the determinant, we can determine whether or not we even need to look for a matrix, which we saw yesterday was a somewhat involved process on its own. Okay. Here is a formula that allows you to find the matrix. Now, again, find the inverse. Again, we kind of breezed over this in class, but I don't particularly like this method. I think it's a little too in-depth. If you want to memorize it, go for it. Okay. But this just illustrates that you end up with a 0 in the denominator is basically what it boils down to. Anyway, all right. So, determinant of a 3 by 3 matrix. This is a bit more involved. Okay, so it's expansion by cofactors. Now, cofactor. Oops. We don't need Windows Media Player. Uh-oh, getting mad at me. Well, there we go. We're back on it. All right. Let's ignore that for a moment. Expansion by cofactors. A equals. Then we just have a bunch of terms in here that we label using these values. Now, this is what the actual determinant is going to be, but we can break it down, and we're going to see that there's actually a really easy pattern that allows us to do this. First off, what we're going to do is we're going to choose a row or a column. In this case, I chose a row. And you notice ABC, those are these values right here. So it's going to have something to do with that. Now, when we start, we're going to start with the first term in that row, A, and we're going to cross out the row and the column that it's in. Well, if you notice, that just leaves us with EFHI, which is this first matrix right down here. Okay. Now, again, we're going to use these pluses and minuses to append it on, and I'll show you that a bit more in a sec. Okay. But you can see here A is going to be positive, so I can just leave A as is. Okay. Now we move to the second term, B. Well, I'm going to do the same thing. I'm going to cross out the row and the column that it's in, and that leaves me with the matrix D, F, G, I, which you can see clearly right here. Okay. Okay. And lastly, we do C up here. I'm going to cross out the row or the column in the row that it's in, and that leaves us with this matrix, which you can see is what we're going to multiply C by. Oops. And you know what? That went away. But if you notice, we had that plus, minus, plus, and this just keeps going. It just alternates back and forth. But here we just have a 3 by 3 matrix. Oh, class is starting. Here I have minus, plus, minus, and then I have plus, minus, plus. And you can see that it alternates with every row and column. It's just alternating back and forth. And so we have the plus here. Okay. And then the next one we're subtracting because we have a minus right where the location of B is. And then lastly, we have another plus, which we're going to append right in front of the C. Now, it doesn't matter if A, B, or C are positive or negative. These plus and minuses are absolute. They're always going to be there. So let's go ahead and look at a straightforward example here. All right, so here we have a fairly straightforward example, or just kind of a regular everyday example of finding the determinant of a 3 by 3 matrix. So we're going to follow that same process that we did before. And we have, it's a good idea to just kind of throw up this plus minus thing so you know which cofactors are going to be positive and which ones are going to be negative. Okay, and then we take our actual matrix here and we're going to break it up. Okay, so I'm going to go ahead and use the first row once again. We're going to have the 3, and then we cross out the rows and columns, and we get 5, 0, 4, 1 for our first one. Okay, minus, and again, this is a strategy that you can use. It's a lot of writing, but if you just write minus, well, I know the next one cofactor is going to be this 4 right here, and that's negative, so I'm going to subtract whatever this determinant ends up being. The 4, we're going to cross out the row and column, and we get our new matrix that we're going to multiply by 4. And you notice that even though the 4 is positive here, I'm subtracting it. So it's going to I'm going to end up with a negative there. And then the last one, well, we can see here that that one's positive. Okay, so whatever this determinant ends up being, I'm going to add it to the other determinants. Okay, cross out the row and column for 2 and multiply that cofactor. I'm sorry, this was a negative 2. Negative 2, we're adding it, times the matrix that's left over here. Okay. Now from here, these are 2 by 2 matrices, which we saw are much easier to go ahead and solve. So I would abandon this method, even though we could apply it to 2 by 2 matrices as well, and just do kind of our cross product method here. Okay. So 3, and then we're going to take the 5 times the 1 and subtract the other cross product, the 4 times the 0. Okay. And then we just we redo that process for each one here. So I'm going to take the 3 times the 1 and subtract negative 1 times 0 here. And then we do that one more time. Okay, 3 times the 4, and then we subtract negative 1, or the negative 1 times the 5. Okay, and that all has to do, again, with this positive plus minus part right here where we got all our positives and negatives from. Okay, then we do some arithmetic, we add them up, and we find that we have a determinant, and we would write that like this. The determinant of A is equal to negative 31. Now, one thing I'd like to point out is we can actually choose any row and any column. And since each one of these, if you notice, since we chose this row right here, the first row, we multiplied by 3, -4, and then by -2. Now, there's a number in this matrix, and go ahead and discuss it with your neighbor while I'm kind of going over this, that would be a lot easier to multiply by, and it's something that we want to get in the habit of trying to do. If you haven't figured it out yet, that is that if we had chosen the third column or the second row, my big eraser, okay, so if we had taken the third or the second column or the third row, what would we have multiplied one of our matrices by? Well, it would have been by 0, which makes life a lot easier. So if you can choose a row or column that has zeros in it, highly recommend it. All right, so for this one, I wanted to show you an example. Again, going with that thing I said, if we choose the right row or column, it actually makes our job a lot easier. So looking at this one, I want you to take about 10 seconds. I'll be quiet. And I want you to determine which row or column would be easiest to use to find the determinant of this 3 by 3 matrix. All right, so I'm hoping that the majority of us were able to determine that we would use the second column. Again, we have these zeros here. You're looking for the column or row with the most zeros. That's what it really boils down to. So looking at this, first off, we're going to start out. We have a negative because that -1 is in this position here. So I have -1, and then I circle that term. Okay, cross out the row and column it's in, and that gives me my new matrix. And again, you see the negative is independent. We're using the negative because it's right here, and then we still have the cofactor of -1 that we put in. Okay, now the next one, well, that one's going to be a plus sign. And our cofactor for this one is 0. Okay. Well, 0 times any matrix, we're going to distribute that to all of them, so it ends up just being 0. Well, that's pretty nice, right? Well, then I move on to my final one. That's 0 right there, and we see that this one would be a minus, but my cofactor is just 0. So I'm going to, again, multiply it by all of this and just get 0. And again, even if I crossed that out, I kind of skipped over that. If I pick this 0 here, I'd cross out this row in this column, but it doesn't matter what that matrix ends up being. Same thing here. If I choose this 0 here, okay, again going down this first column, that's going to cross out these two terms in this column, but again, I would end up with 0, 3, 4, 3, but I'm just going to multiply it by 0, so I'm left with 0. And this actually, I'm sorry, this should be this should actually be a subtraction symbol. Okay, but then we just determine that matrix, again, 4 times -3 minus 2 times 3, or 3 times 2, and that will give us our final determinant of -18. Okay. All right, if you have additional questions, feel free to shoot me an email. I will try to get some homework examples up tonight if they are requested, and please complete the classwork for the rest of the period.